So welcome to my channel, Electronics on Wheels. So thank you for all your support, and you are viewing the videos and getting help by this. And this is my only target, to help you and giving back to the society whatever I have gained from, from all the experience which I have for 20 years, 25. So one of our subscriber has asked one question 2 weeks ago. So as you know, I am little busy and I don't get the frequent time. So I am taking one by one your question, and I will come back to all the questions and will try to give the answer of all the questions. So one of our subscriber has asked that, can you please make a video on bundle dia calculation and ground terminal selection? So I would like to tell you the bundle dia calculation is very easy. So 10 minutes video I will definitely make, but not now. It has some calculation, it has some formula, and you have to just give those particular value in that, where you consider your core tube and other parameters. But there is a one interesting point he has asked, that is ground terminal selection. So ground terminal selection is a very big topic, and I am going to make 3 to 4 videos on this. So first we will we will start with the basic of the ground, and then we will go to the ground terminal selection. So actual question would be like that, what type of ground terminal, whether I'm going to select M10, M15 or M6, on what basis we are going to select this terminal. But before going to that, I am going to tell you about the ground concept, how this evolves in the automotive vehicles, and what is the advantage to keep the grounds on vehicle, and we have to sometimes keep in the separate dedicated grounds. So all these questions I'm going to answer first, and then we will go to the ground terminal selection. So this is the video which is helpful for everyone, whether you are from the automotive background or not, but it will definitely help you to understand how ground works in the vehicle. So moving to the next slide. So before moving to the next slide, so please, as I have already told you, please like the video. Um, if you like the content of this channel, so it is pure technical and you learn a lot. This is the learning where you don't get in the books. You get the practical experience here in this channel. So please like, subscribe and comment on this. So I am targeting, like, if at least the 20% or 30% of the viewers, like, if I get, then I will definitely make the further videos on this topic. So if suppose 100 people are watching, at least 30 likes if I get, I will definitely going to make the video, so that at least I will also get, okay, the people are getting helped by these, and they are these videos are making sense to them also. Otherwise for me also it is like a time wasting. Okay, so without wasting the time, we are just moving to the next topic, that is grounding and ground distribution, how the vehicle have the ground distribution in the vehicle, and what are the techniques and what are the topologies we are using in the vehicle. So there are a lot of questions, and you will get lot of questions in interview on this ground distribution. So first we have to understand the what is the ground in the vehicle. So ground, if you ask to any layperson, he will say that it is like earthing. So definitely earthing is nothing but is the 0 volt. Okay, so definitely here also this is 0 volt, but here we will just go in a more detailed way. So here this ground is also making one loop. Okay, and that loop is doing what? It is completing the circuit. What circuit it is completing? So one side, if I am taking, this is a battery. Okay, so suppose this is my battery, here my positive, here my negative. Okay, and this is my load. So if from one point, from the positive, it is going here on a positive side of this load also, and then I am completing this circuit through the return path to the current, right? So here, this is how your ground works. Okay, if suppose you don't return this part to this ground, then your lamp will not on or off. Okay, whatever function you are doing with that. So return part to the circuit or to the battery is necessary. Okay, but you might be wondering that when you have the vehicle, and in vehicle your battery is in front, and there are many loads which are in the rear side. Okay, but in rear side, when you are having battery here and negative, battery positive here and negative here, so you are not going with like that positive wire. You have to flow, you have to take from battery positive post to the load. But when it comes to the negative, so you might have seen many grounds in the your rear side itself. It does not come to here. Okay, it does not come to here. So your question would be how it is completing the my circuit path. Okay, so I will tell you. So the basic concept is like battery, that would be the power source, and ground, that will complete your return path back to the ground of that particular source. But what happens, your vehicle is made of all metal. Okay, all metal, therefore it conducts the electricity, okay, through one point to other point. So if you might have seen this negative point, so there would be a negative wire, okay, negative cable, negative harness, and that would always would be on the car's body or whatever vehicle you have, whether you have the cars, whether you have the trucks. So on this particular, it would be on a chassis. Okay, on chassis, vehicle body, whatever you say. What happens when your whole body of your car is on metal, then metal can pass this particular current to this, right? So when you are grounding on this metal or chassis on this point itself, then this particular circuit completes by like this. Okay, so def you know rather than, so in this case what you were doing, you were doing the positive, negative, and this is my load. Okay, suppose this is my load. So what you are doing, one wire you are taking from positive, and then if you want to make the circuit, then you are taking one another wire to the negative. But when you are grounding through the chassis, what happens when your whole body of vehicle is of metal, then what happens, it completes the circuit, it completes the circuit through your vehicle body. So here, what is the advantage and what is the disadvantage, we will see here. So what it's saying, so rather than running two wires, sorry, rather than running two wires to every device, okay, we put wire between the battery negative and vehicle chassis, vehicle body, whatever you say. The understanding is only that your vehicle body is all metal and it is passing or returning back that path through the vehicle body. Okay, so now whole vehicle is effectively return loop, allows the current to flow back to the battery. This is the concept. Okay, I hope you understood. But you have seen there are two types of things. One is where you are putting one wire for positive for one load and other wire for the negative, right? But there is a second case. This is the first case. Second case, what you are doing, your battery is here but my load is on the rear side of the vehicle. One positive wire I have to do, there is no other option. Okay, but when it comes to ground, I just ground on the vehicle chassis near to that load, so that I am not required to take that wire from battery positive to back to here. Okay, if you are taking, so what will happen, the cost will involve. So we will discuss these point pros and cons. So from there, this concept of one wire and two wire comes into the picture. I will explain in detail in the coming slides. So the next question comes in your mind, so whether this chassis is equals to ground. So yes, so as a practical or theoretical, if sorry, theoretically if you say, so this is works, but there are many things which plays behind this. Okay, there are separate, you might have listened that there might be a separate single ground wires as well for the body, and those wires are dedicated for that particular issues or particular function. So why this happens, we will see in the coming slides. So the second point, what it is saying, that it is all too easy to look at this wire and say, okay, ground is ground and it just loop back to the battery. But it is not that simple. While it is very tempting and quite possible to connect all the black wires to the chassis about anywhere, it is not definitely advisable. So suppose your question here, the statement, I just make it simple. So suppose you have 10 devices in the back side of the rear of your car. Okay, so what you will say, you will say that, okay sir, I am going to ground this particular device on, I will take one 50 mm of wire or 20 100 mm of wire, and I will just ground like this, single wire. Okay, but there are many factors which plays in the role that you cannot put this ground like this. And what are those factors? The first factor is the voltage drop. And in voltage drop depends on many things. And voltage drop, in the vehicle plays a very vital role when it comes to the sufficient power to apply it for that particular function to run. Okay, so what are the factors which plays a vital role? That is length of the wire, then wire gauge, then amount of resistance in the wire. Okay, you know that if more resistance, more heating, more voltage drop, and most of the thing. Then wire gauge also, that whether you are using the higher cross section wire gauge or the lower wire gauge, that what is the length, more voltage drop, more resistance. Number of joints, how many number of joints are there? So suppose there are too many joints are there, then more resistance would be there and more voltage drop would be there. That amount of current flowing through the wire. Now how much current is flowing through the wire, right? So suppose if higher current is flowing, then there would be a heating effect, and it can burn your um, wire. Okay, so these are all the factors which plays a very vital role in the voltage drop. And we will see how the ground we cannot put for 10 different devices on a 10 different places, and that is the reason that it plays a very vital role to giving back to this the negative of the battery. Okay, so I'll just move to the first wire and second wire concept. So this is nothing but the ground zero voltage. That is what we have uh, you know discussed earlier. So this is the two wire concept. Okay, so this is the first wire and this is the second wire. Then what is the single wire concept? So single wire concept is this is your battery. This is your battery positive, and this is your battery negative post. Then this battery negative post, one wire cable, you have taken 100 mm 100 mm or 500 mm wire, and you have just given this ground to the vehicle chassis or vehicle body, and after that all the loads are connected through the local grounds to the different location of the vehicle body, and return path is given through the metal of the car. Okay, metal body of the car. So first, the type of ground, single wire. Single wire connects from the source to load. Then source is this, and this is our load. And ground or return path is given through the vehicle body. This is what I have explained you. So single wire, that your battery is there, and then you are not taking it back. You are just giving it here only. And this particular path is completing through the vehicle body. The negative of battery is directly connected to the vehicle body. Ground connection to the individual electrical loads are connected through the local ground points on the vehicle body. So this is the concept of single wire. Now coming to the what is the pros and cons of this single wire. So first is the low cost, weight, and ease of installation. So simply I have told you the low cost. Why low cost? When you are going with this particular method, then you are running two wires from battery to the load, one for positive and other for the negative. So there are two wires. If two wires, then there would be higher cost. But when I am going with a single wire, then there would be a low cost. So that is the low cost. Then weight, simply if you are using one wire, there would be lesser weight. Ease of installation, definitely you are not running all this wire, negative wires to the battery. So if you want to check or you want to install something, then it would be easy for you. So these are the pros of this particular single wire. And I want to tell you, most of the time the single wire ground topology we are using in all the vehicles. What are the cons? Then aging and environmental factor, what are those? That got rusty over the time, definitely, like this you can see here. That increase in contact resistance, which leads to higher voltage drop, and it leads to the loss of signal. And if leads to the loss of signal, then your function will not work. And if your function will not work, then what will be the use of that particular wire? Nothing, right? Then insufficient power to the load. Of course, when you will be have the higher voltage drop, then it would be insufficient power to the load, and chances of burning the wire are higher. So this is the type of ground where we have discussed about the single wire. Okay, and what are the advantage, what are the cons, pros and cons. Okay, then I have given one picture. So this is how this our ground is look like. This we call is the HST. Okay, this particular thing is we call HST. And these are the things which we have shown, that you are not allowed to put your ground like this. Okay, we never tight like this screw. Okay, we always put with the bolt, and to more tighten or more it should not be loosen, so we put the washer as well. Okay, you can see here. So there are different type of ground nuts and eyelets are there. So we will discuss all these points in detail in the coming videos and coming slides, where you can put like this, how many maximum ground points you can put on one one bolt. Okay, and what type of arrangement of this particular ground eyelet we have. Okay, moving to the second one, that is two wire circuit. Two wire circuit is nothing but which I have already explained. So in this is your load, one wire for positive, one wire for the negative of the battery. Okay, so one is supply for, other wire is for return path. Pros, what are the pros? That reliability, definitely good for safety system for grounding. What is the cons? Higher cost and weight of the harness would be increased. Okay, so good for the safety system on a grounding, I will tell you, and it very beautifully works on an issue, and I will show you where you have the critical loads and you have to give the separate grounding or dedicated grounding to avoid any resistance increase or the losing of that particular ground. If you are losing that particular ground, then your function will be not working, and if your function is not working, then it is a very difficult, like airbag. Suppose airbag and your airbag ground is not properly connected, then it is a big problem. Okay, so I will discuss all these things in detail in coming videos. So type of ground strategy we will discuss. So first, so ground load grouping, we decide based on the load nature. Okay, so we can group the loads based on the load nature. Okay, so I have given you one example, like suppose I have 10 loads. So should I give single wire for all the loads, right? So this is not a good way of giving the grounding. So what is the strategy? That we will group the loads, but how we will group the loads, that will depend on the load of the nature, load nature. Okay, nature of the load. Then we will see the how we can club the different type of load based on the nature. Okay, so there are three types of load you have. One is inductive load, resistive load, and then the capacitive load. Okay, so these resistive loads are very good for your system, but inductive load and the capacitive loads, these particular two loads plays a very vital role when you are grouping them. Okay, so mainly two types we have divided. So what we have divided, clean ground and dirty ground. So dirty ground is not this dirty ground. I'm not talking about this dirty ground. Okay, dirty ground in which sense? Suppose you are mixing the inductive and resistive load. Okay, in that type, what will happen? Inductive load, what will happen? Inductive load, what is the example of inductive load? That is motor. Okay, door motor or window motor. Okay, what will happen? Inductive load will be having the transient current. Okay, transient current or peak current, you can say, or you can say rush current. These rush current plays a very vital role sorry, when you are defining your ground strategy. Okay, so we never or we cannot say never, but we can say we try to avoid the inductive load with the resistive load. Okay, we don't sorry, mix all these loads, inductive loads and resistive loads together. So we have the clean ground and dirty ground. So you understand what is dirty ground? Dirty ground, if you are mixing the inductive, capacitive and resistive, that is dirty ground. Clean ground are those grounds which are resistive grounds. So ECU ground, resistive grounds, where you have the current on a particular range. Suppose 5 ampere, 10 ampere, 3 ampere. So it depends on the OEM. They have some standard, and based on that they decide how much current they have to take as a clean ground. But this should be resistive load, and your current should not be on a higher side, it should be on a lesser side. And ECU ground is comes under the uh, clean ground. Then you have your sensors. Okay, then what are the examples? You have the OBD connectors, diagnostic connector, then engine sensor, lambda sensor, oxygen sensor, map sensor. There are many sensors. So those comes under the clean ground. Then LED lamps we have, then switches we have. Okay, so these grounds comes under the clean ground. Okay, so we can combine these grounds when we are grouping them. Then we have the dirty grounds. So dirty grounds are classified on a below factors. So resistive load, but when your your current is on higher side, like greater than 5 ampere, or you have the transient current. So transient current comes in the inductive loads, that is your motors, okay. Solenoid also a inductive loads where you have the magnetic field and you have the chances of uh, transient current or the peak current or the rush current arising. So what happen in transient current, that it goes a very high peak of current goes, and then it settle down like this, okay. But it creates a many things in your system. So that's why we try to avoid these particular grounds in a separate, okay. Then what are the example? Motors, horns, lamps where you have the inductive nature, then you should avoid these particular grounds. So I hope you have understood this thing. So we have seen ground concept, then we have seen the type of ground where you have the single wires and two wires. Then we have seen the ground strategy where you have the clean ground and dirty grounds, okay. Here one example I have given. So this is my battery and this is my positive. Then you have the battery negative here on a engine block, and here also you are giving this ECU, this particular, and ECU ground you have given to this engine block also. So what happens? Suppose you have taken your wire, this wire. Suppose I have taken 10 square mm, okay, and I have taken this one is a 20 square mm, this I have taken 5 square mm, okay. So suppose there are chances that your this particular wire, okay, is got failed, okay. But I want the grounding circuit, okay. I want to get the return path, okay. So what it will take? So suppose this particular thing will not take from here, but it will take from this particular thing, okay. So what happens? That suppose you have designed this particular wire for 20 amps, okay. But when this particular ground wire is not working, then there would be chances that all the loads which are connected here will pass through this, and your wire will burn. Suppose I uh, if I'm taking all the return path from this wire, and you have designed for 20 amps for 5 square mm, but because of failing this particular wire, all my ground is taking from this, okay. Then what will happen? Then suppose 40 amps of current is flowing through this, then what will be the happening? That your wire will be burned out. So coming to the packaging of the ground, okay. So I'm going to discuss in detail how to do the packaging of the ground and what type of grounding we have. We have the folding line, then wet zone, dry zone, the type of hardware used for ground, harness side, what is there, mounting side or vehicle side, what is there, weld nut type or stud type, and threaded types. So all these grounds I'm going to discuss in the next video. But if you like this content, please like, subscribe, and share with your friend if it is really helping you. It will be great. And as I told you that if I get the 30% of the viewership of like, then definitely I'm going to come with a new video. Thank you. Thank you for your support.